Hello, this is Professor Stephen Nesheba, and I'm here to help you out with the some of the calculations having to do with the H2O2 rate law lab. So what I've done is I've laid out an Excel sheet like this, more or less in parallel with the table in your handout, and I'd recommend that you get that all set up as well. Okay, so when you're back, now you notice what I've done here is I've entered in, here it's 1 mil for run 1, 1 mil of Ki, and so on, and this is the amount of water, and I've also gone ahead and entered the slopes from the experiment, and but the next thing I want to do is calculate the amount of Ki that's actually in the solution. The way that we're going to do that is I'm going to say equals, well, remember it must be the stock concentration, which is 1 molar, and I'm going to multiply that by a volume ratio, and the volume ratio must be the milliliters of Ki divided by the total mils, which is 25. Okay, so I put that in there. Now, if you want to try the same thing for the H2O2, I'd say pause and then resume. Okay, what I think I ought to do is pretty much the same thing here. I'm going to say that's equal to the stock concentration of the H2O2, which is 5 molar, and I'm going to multiply that by the dilution factor, which is that box there, divided by 25. Remember, it's 25 mils in each one of those solutions. Okay, now the nice thing about this, of course, is that I can take those two and drag them to the right. And so that's what I've done there, and drag these off to the right as well. Okay, so that's good. And you notice, of course, that because it's all relative addressing, it's updating those fields appropriately. Okay, now what are we going to do about calculating the change in H2O2 with respect to time? Well, we need this separate equation for that, which I'm going to go up here. This is the equation we want right here. So I need to enter this formula here, and your numbers will differ a little bit because you'll have a different temperature and so forth, but I'm just going to kind of show you how to do it. So I'm going to say, well, that's equal to, and minus 2, that's what this is requiring here, times, now I need to open parentheses, volume of the air. Well, that would have been different for yours, for each experimental apparatus, but I'm going to say, let's suppose I had 3 mils upstairs. And downstairs, now I need RT times volume of the solution. If you recorded your pressures in atmospheres, then this R should be in the liter atmosphere system, which is 0.082. And I multiply by the temperature. Well, I think my temperature was 293. Yours might have been different. And now I need to also multiply by the volume of the solution, which in my case was 25 mils each case. And now I got to close all those parentheses. Now I need to multiply by the the slope of the pressure, but that's that box right above me right there. So I'm going to do that. Oops, I need to say times that. Okay. And now if everything's fine, I get that number. Okay. What are we going to do for the rate? Well, maybe you want to give this a shot. It's this next equation. Okay, well, I think what I should do for the rate is just key in that expression, so that's equal to, now I need a minus 1/2 times, that thing that I just calculated up there, so I'm just going to go click on that guy there and hit return. Okay. Now, finally, what we want to do is, it'd be nice to get the rate constant, and that's going to be based on this thing here, and that's going to depend on what I think M and N are, so I'm just going to make up some values here to show you how to do that. But you see, if you take this expression and you solve it for K, what I'm going to end up with is the rate divided by those concentrations raised to the appropriate orders. So if you want to do that, why don't you give it a shot? Okay, here's what I'm going to do is I'm going to say equals, so this is K I'm solving for, it's the rate, well I've just got that one, divided by, and now I'm going to have two things in the denominator, the concentration of H2O2, that's already there, okay, and let's say, suppose I think it's first order in H2O2, so we'd be done with that one, times, now what else do I need, the concentration of the iodide, okay, so there we go, that's that one. And if I thought that it was second order on iodide, I would enter in something like that. And I think I'm done with that now. Okay, so now that means I've got a rate and a rate constant, and I can shift these. I can actually fill across all three at a time like this, just by highlighting all three and moving them all across like that. And okay, and so now I've got some data here, and if I wanted to do one more thing, let's suppose I wanted to get an average of the rate constant. Well, that I can also do that. It's pretty straightforward in Excel. I want to say that's equal to the word average. Okay, and you need to open the parentheses as I've done here, and so this is finishing up here. I can do that. Come on, open parentheses. And now I highlight the three boxes that I want to take the average of, and close parentheses, and it gets me an average. And so there you have. I have now the average of the rate constant, which is right there, average. Okay. And so this should save you quite a lot of time in your analysis.